signs are basically the protocols to be followed while making ray diagrams in the case of mirrors as well as lenses. So the first one is the object is always placed to the left of the mirror. This implies that the light from the object falls on the mirror from the left hand side. The light from the object, the image from the object which we'll be getting from the light of the object is coming from the left hand side. All distances parallel to the principal axis are measured from the pole of the mirror. The pole is the point where the principal axis intersects with the mirror. Okay. Third one, the all distances measured to the right of the origin along with the positive x-axis are taken as positive, while those measured to the left are known as minus x-axis and positive, while those measured to the left are known as minus x-axis and will be taken as negative. So I can say on the left hand side we are taking positive and on the right hand side negative. Now next one, distances measured perpendicular to and above the principal axis means along positive y-axis are taken as positive, and similarly downwards they will be taken as minus y-axis. So okay, these are the basic rules. These are easy to remember, and the values of the image distance u, v will be taken on the basis of these. So let's get moving. Spherical mirrors. So spherical mirror is nothing but a part of a whole sphere. The mirror is a part of a whole sphere, and the C is known as center of curvature. Center of curvature is basically the center of the sphere of which this mirror is part of. Okay, if you continue drawing the mirror, it will form a complete sphere, and the focus is the distance between the F, which is the focus of the mirror, and the distance between focus and the pole of the mirror is known as focal length. Okay, and the distance between the pole and the center of curvature is known as the radius of the curvature, radius of this mirror. Okay, so in the first case we are having a concave lens, and the image is coming, object is at infinity, parallel rays are coming, the rays are parallel to the principal axis and they all intersect at the focus. So what is this? This is basically the concentration. So for example, if that at infinity we can take sun. So rays are coming from it, the concave lens converges the rays and they all intersect at the focus at one point. So basically we are having the image of sun at the focus point. So the intensity is so high that it may even burn the object or the screen due to intensity. Okay. Next one, we are having a concave mirror, and the object is again at infinity, the rays are coming, but in this case, in convex mirror, the focus is taken on the right hand side, not on the left hand side, because it tends to diverges the ray. So rules are quite inverted in this case. Okay, so as you can see, all of them tend to coming from the focus. You can see clearly. Okay, and remember the radius of curvature is twice the focal length. So you can say the focus is always in between pole and the center of curvature C. Okay, so moving on. A ray parallel to the principal axis. After the reflection it will pass through the principal focus in case of a concave mirror, which is the A part, and or appear to diverge from the principal focus in case of convex mirror. This is easily can be seen. Okay, a reflection in incident ray, it is very easy. So okay, so moving on, ray passing through the principal focus. I told you what is principal focus. Okay, it is in between the curvature and the pole, and in the concave lens it is coming. Focus of a convex mirror after reflection will emerge parallel to the principal axis. This is illustrated in the following figures. You can clearly see it. Moving on, a ray passing through the center of curvature of a concave mirror or directed in the direction of the center of curvature of a convex mirror after reflection is reflected back along the same path. You can clearly see it is reflected along the same path, going back. The light rays come back along the same path because of the incident rays fall on the mirror along the normal to the reflecting surface due to the normal. It is same in the case of convex mirror. So it is basically same in convex and concave, but the basic difference is that in convex case the focus and curvature are behind the mirror. Okay, so moving on, the ray incident obliquely to the principal axis. It is obliquely incident on the principal axis towards the point P, which is the pole of the mirror. On the concave mirror is reflected obliquely. The incident and reflected rays follows the law of reflection at the point of incidence. The law of reflection is angle of incidence is always equal to the angle of reflection. Okay, so this is basically the application, or you can say a pure example of laws of reflection. Moving on, so image formation by a concave mirror for different positions of the object. We are having various cases for various positions of object and various positions of images for the concave mirror. In first case, position of the object. When the object is at infinity, it will be at the focus. Size of image will be highly diminished, and point sized. Point sized, that means it will be highly concentrated and intensified, and the nature of the image will be real and inverted because it is being reflected. So in almost all the cases it will be inverted and real. Okay, this will be shown to you in the next slide. And next case, when the position of the object is beyond the curvature, because okay, and the position will be between the focus and the center of curvature, and the size of image will be diminished, will be quite small but not intensified, and again it will be real and inverted. At center of curvature, then the position of the image will also be at the center of curvature. So this is very easy to remember. When the position of object is at curvature, the position of image will also be at the curvature, and the size will remain same size. Okay, real and inverted again. Now next case, between center of curvature and the focus, and in that case position of the image will be beyond the center of curvature, and it will be obviously size of the image will be enlarged. You can clearly see in the next slide when you will be seeing the ray diagram for it, and again real and inverted. So again the various cases, and the last one, between the pole and the focus. Now this time the position of the image will be behind the mirror. It's quite like the convex case. Behind the mirror, the size of image will be enlarged, it will be magnified, and obviously now the nature of the image will be virtual and direct. It has to be virtual now because the side will be changed. Okay, now I will be showing you the diagrams. For the first case, you can see they all are intersecting at the focus. The image will be formed at the focus. And now in the B case, C and D, you can see all these cases. So you have to study them clearly, and the ray diagram should be, when you are drawing the ray diagram, they should be clear and sharp. Always prefer scales, and don't try to draw rough diagrams. Okay, this is the last one. Now you can see the last one, the virtual and erect case. You can clearly see it is forming behind the mirror. The image is formed behind the mirror. Okay, now moving on for the case of convex mirror. Now in the convex case, we are having only two cases when the position of the object is at infinity. At infinity means at the focus, the image will be at the focus but behind the mirror, and the size of the image will be highly diminished and point sized, kind of the concentrating kind of thing. And the nature of the image will be virtual and direct. All the natures of the images in the case of convex mirror will always be virtual and direct, as you know, because all it is considering on the right hand side. You can see the first case. This is the one. It is meeting at the focus. Okay, clearly you can see it. And the second case, between infinity and the pole of the mirror. Then the image will be between the pole and the focus. Okay, behind the mirror. Again behind the mirror, but in this case the size will be diminished very small, and it will be virtual and direct. This can be clearly seen in the diagram. Okay, so best of luck. We'll be studying further topics ahead. Okay, so okay.